Safety of places like hospitals, schools, or high-rise buildings, which gather a large number of people and uninterrupted operation of power station, mine, or industrial plant, is directly dependent on the fire safety of electrical equipment. According to statistics, in 30% of cases, the cause of fire is a malfunction of electrical equipment, which leads to material damage caused by fire, stop of production and profit loss, hazard situation for lots of people. Let's have a look at this issue in greater details using the example of a switchgear. The most dangerous and most likely cause of fire here, as with any MV or LV equipment, are contact connections because of their possible loosening, especially the ones made on site. Contacts may be loosened by improper tightening during assembly, constant vibration during operation, large number of closures openings for withdrawable circuit breakers, temperature fluctuations during the day, heating at high currents and cooling at low currents expands and squeezes the contact with subsequent weakening of it. And even if an insufficiently tightened connection still provides an acceptable level of mechanical reliability, it worsens the electrical reliability. Since the connection is loosened, its resistance increases and overheating begins. Heating due to the increased resistance accelerates the oxidation process, which is faster at higher temperatures. Oxidation covers contact with an oxide film, which has a much higher resistance than the base metal. Due to the oxidation of the contact, its resistance increases, and each time the heating of the contact becomes stronger. As a result of this process, the contact and cable insulation are completely degraded. Thereafter, any overheating of the contact can lead to an uncontrolled rise in temperature, resulting in a fire in the electrical panel. Process of contact degradation and insulation deterioration can take several months, but the result will be the same: fire in electrical equipment, material damage, stop of production process, and a threat to life. Existing preventive solutions, such as scheduled inspection with a thermal imaging camera, are not very effective due to long periods between inspections, limited visibility, necessity of sufficient load at the time of inspection, and risk for maintenance personnel. The best solution for this problem is using FIPRES, Continuous Overheating Control System. The system consists of three main products: Remote Fire Prevention Thermal Label, RFPT, Fire Prevention Alarm, FPA, and Fire Prevention Concentrator, FPC. RFPT sticker should be simply glued close to contact connection. It doesn't require additional accessories to install and is very convenient to use. We recommend RFPT on each connection of power circuit, especially contacts of circuit breakers, disconnectors, incoming cables, fuses, current and voltage transformers, capacitors, and bus bars. An FPA is then required inside the electrical panel. RFPT has thermal indication dots with different temperature levels of indication. As the connection heats up, these points irreversibly change their color to black depending on the degree of overheating. It gives clear information to maintenance personnel regarding overheating that had occurred and allows to improve the efficiency of inspections. When the contact is heated to the activation temperature of RFPT, the sticker releases a colorless and safe signal gas. This signal gas is detected with high accuracy by FPA sensor, and it goes into alarm mode. Immediately after that, FPA sends alarm signal to SCADA system via Modbus and to any external system via dry contact output. FPA can be connected to an external system through FPC. It has a display giving information about the status of connected FPAs, access to events log, and information about triggered FPA in case of receiving alarm signal. FPC is also equipped with speaker for audible warning. FPC can simultaneously receive information from 32 sensors and transmit the information to the SCADA system via Modbus or to any external system via dry contact output. The version with the GSM module can also send an SMS message to the duty personnel with information about the triggered sensor. After receiving the alarm signal, the maintenance team should inspect the problematic equipment and make repairs, clean the contact from the oxide film, tighten the weak contact connection, make other repairs if needed. When finished, the RFPT sticker should be replaced with a new one. Now, this point is fine and will not lead to a dangerous situation in future. Thus, the FIPRES system allows service personnel to identify problem connections at an early stage, long before a dangerous situation arises. It provides 24/7 monitoring of overheating and allows to increase the efficiency of the inspection. FIPRES can be installed in electrical cabinets up to 3 cubic meters, allowing quick and easy installation of the system in both new and existing facilities.